if you want to be the tallest person in Union County, there you go. Now, my name is Travis. We'll be your program presenters, telescope operators, drivers, code cashiers, basically everything. So if something goes wrong, blame him. Thank you. Now you can see that we have a bunch of telescopes up here. That's because this area of the country is absolutely fantastic for astronomy. And so pretty much every mountain in this area has telescopes on top of it. One of which you can actually see from this location. You come a little bit closer to me and you look way off into the distance. At the farthest mountains, right between this tree and that kind of wooded peephole, you'll see a peak, a little divot, and another peak. And right between them, you may be able to see a little gray dot. Now, that little gray dot that you may or may not be seeing is actually an 11-story building that houses the largest near-infrared and optical telescope on the planet. That is the LBT, the Large Binocular Telescope. It has 2 mirrors, each of them 27.5 feet across. To give you an idea of scale, a single one of these mirrors is the size of that dome. But it has 2 of them. Now, these mirrors were built at the University of Arizona, right here down in Tucson, Richard F. Harris Mirror Lab, which is nestled right underneath the football stadium. Yeah, you could say it's the most important thing that happens at the football stadium. And they actually offer tours where you can see these massive mirrors being constructed. Has anybody visited the Mirror Lab before?
Say that again.
Which part?
Has
Has anybody visited the Mirror Lab before?
No.
Would you recommend it?
Yes.
Completely unbiased review right there. Yeah, you have no idea how massive these mirrors are until you see not one, not 2, but multiple within their facility at different stages of manufacture. They're actually an assembly line, so they're actually working on multiple mirrors at the same time. Right now, they are currently working on the Giant Magellan Telescope, which will have 7 of those 8.4 meter mirrors, 20 tons each. Really, really, really awesome.
Are all of those with Stewart, operated by Stewart, or all of the
No.
They're all different?
A lot of them are. The U of A definitely has its fingers in a lot of them, but a lot of these telescopes are from lots of different groups, and telescopes like the LBT, they're so massive, so it's expensive that they kind of work like a timeshare. Multiple groups actually buy into it, but based on how much money you put in is how much time you get for the telescope. So for the Large Binocular Telescope, about 25% of its time and funding was by the universities of Arizona. So University of Arizona, ASU, Arizona State University, and Northern Arizona University, NAU. Now, there are 2 other telescopes over on Mount Graham. There's a 10-meter radio telescope called the SMT, as well as a 1.8-meter telescope called the VAT, which stands for Vatican Advanced Technology Telescope. This is actually a telescope that's owned by the Vatican and operated by Jesuit priests who have PhDs in astronomy and do real research utilizing the telescope. Of course, we refer to it as the Pope scope, or the telephone. It really does depend on it.
Is that 11-story building? Is that on Mount Graham also?
Yeah, so that building is the Large Binocular Telescope.
On Mount Graham.
On Mount Graham.
Okay.
Yeah,
Thank you.
10,500 feet, give or take.
Thank you.
10 feet. You got it, depending on if you include the 11-story building. Now, Mount Graham is not the only mountain in this area. In the exact opposite direction, about 57 miles away, is Kitt Peak National Observatory. It's one of the largest collections of telescopes anywhere in the world. How many telescopes are currently on Kitt Peak? 24 telescopes. The only mountain that I know of that has even more telescopes is 52 miles directly south of Tucson, and that is Whipple Observatory on Mount Hopkins. They have about 33 telescopes on the mountain. Now, some of them are like really, really tiny, so I don't know if you want to count them individually or not, but we have a lot of telescopes in this area.
And they're all looking and doing different things.
Completely different
Every
things.
mountain and every Wow.
So,
A lot of data.
for instance, on the Catalina Mountains, these ones right here, we have 12 telescopes. Down on Mount Bigelow, we have the 61-inch Kuiper telescope, operated by the U of A, as well as the 28-inch Schmidt telescope, operated by the Catalina Sky Survey. They get all of their funding through a NASA grant. Here on the actual summit, kind of down where we're going to be having dinner, is the University of Minnesota 60-inch telescope. They're using that for supernova research, so they're currently in the process of upgrading the facility. A little bit further up the road is a 50-inch telescope operated by the University of Florida. Here on the actual summit, this telescope behind the fire hose, and if you do a little bit of astronomy yoga and you look across the way, you'll see a 20-inch telescope here on my left and a 40-inch over on this side. And these two telescopes are both owned and operated by South Korea. They're actually completely robotized and automated, which means they're actually controlled from South Korea. Because they're on the opposite side of the planet, their morning is our night. It means they have a normal work schedule, which is completely unfair. This small dome on the end of the road on the right-hand side is empty, so we'll skip it. This angular trailer with the blue on the bottom houses a little 8-inch telescope called Lemmon. It's currently being used to study the light pollution here in southern Arizona, as well as track satellites. Right behind that is kind of a barn-shaped white building. That is operated by the University of Louisville for their graduate student program. It's a 24-inch telescope. And then I actually skipped the most important ones up here, which is to say the ones that we get to utilize. Right here is where the bands are, and right behind us are the 32-inch Schulman and the 24-inch Phillips telescopes. These are pretty much the largest telescopes in the world that are dedicated for public outreach in astronomy and remote astrophotography. Many of the other telescopes up here, as you can tell, are larger than ours. However, they are research telescopes, so they have permanently mounted instruments in order to collect their data. There are no eyepieces on these other telescopes, so please don't wrestle me and Geronimo down to the ground and demand you look through something else. We cannot oblige you. That's mini Epcot. So that's a remnant from the Cold War. This was actually the highest continually operational radar station in the contiguous United States between kind of the 50s and 70s. So there's a big radar dish inside of there. Now it's this big empty concrete pier, but because of how tall it is, you can actually see that from some areas of Tucson. It's just a little white blip along the mountain.
Oh, that's what we see then down at an oracle when we look at Mount Lemmon.
If you're in Oracle, you're actually seeing the last two domes here on the very end of the road.
Oh,
Because Oracle is kind of all on that side of the mountain rather than Tucson in that direction.
okay.
These last two are some of the most important ones for humanity. They are part of the Catalina Sky Center. Has anybody heard of them? All right, how many of you have seen the movie Armageddon or Don't Look Up?
That's up.
They're the ones that would actually find the killer asteroid that would destroy humanity. Their entire mission is to discover and track near-Earth objects, or NEOs. And they are the best in the entire world. About 45% of all near-Earth objects ever discovered have been found by Catalina Sky Center.
Who gets that? Alert, alert, alert.
So it is a public database. Anybody can access it. It's called the Minor Planet Center. It's based out of Harvard, but they have servers around the world. They are the clearinghouse. So, and all the data is public. There would literally be no way to hide the data as it comes in. So it's not going to be like Armageddon where some undergrad is eating ramen and then finds something and then suddenly the NSA is kicking down the door and saying, "Tell no one!" Like literally the first people to know would not actually be the observer here, because they're just pulling in the data, getting a rough estimate, and then sending it to the Minor Planet Center. It's the Minor Planet Center that actually would be sending out kind of an RSS feed saying, hey, this is an object of priority, and that is a completely open public feed. Literally a bunch of amateur astronomers are some of the biggest help to these observations.
I tried double. With my telescope, I've done some of it.
Fantastic. So thank you for your service.
It doesn't go to the military to say you need to shoot it down, though, huh?
No, because that is not how you stop an asteroid. I mean, imagine a giant rock the size of a mountain moving at 10 kilometers a second. You're not going to send up Bruce Willis with a nuke. That's
I was going to say, they
not how
do
that
it in the movies.
the movies are sci-fi,
Yeah.
weirdly enough.
Yep. Interesting.
Yeah. There has actually only been 8 times in human history that an asteroid has been detected out in space and then later actually hit the planet. 4 of those were discovered by that 60-inch on the end of the road. 3 of those by the exact same dude, singing in the exact same scene. So he's incredibly lucky, or unlucky. He either is causing them, so we need to fire him, or he's really good at finding them, so we want to keep him going. Now, any other questions before we head inside of our telescope?
My other question is it more than enough to complete their own thing?
To study God's creation. That is the quickest way to talk about it. They have already confirmed years ago Galileo was right. They were wrong. They have grown. Yeah, it is quite fantastic. In fact, the Vatican's telescope, its mirror, was the very first one made by the Mirror Lab. Now, back at the time, they didn't have their facility underneath the University of Arizona's football stadium. Instead, they just had whatever space they found available, which happened to be the basement on campus of a synagogue. The principal investigator and the kind of inventor and creator of the Mirror Lab, Roger Angel. So an angel made the Vatican's mirror in a synagogue. I don't know how much more holy you want to get, but there you go. It also technically has a hole. That's a different type of hole.
Okay.
All right, we're going to go ahead and head inside of our dome. You're more than welcome to ask questions throughout the whole program. There are no dumb questions, there are just dumb answers.
Travis, do you have your own mirror illuminizing facility up here, or do you haul everything?
Everything up here is re-illuminized down, not at the U of A, but at a facility the U of A operates. It used to be the old high school Sunnyside, which is kind of on the south side of Tucson.
Yeah, I was surprised to find out that McDonald Observatory has their own illuminizing facility.
Yeah, and any of these really large telescopes, they have to be illuminized on site.
Yeah.
So LBT is literally just basically just around the floor. They pull the mirror out, do it there. Actually, they don't even do it there. They do it in the telescope assembly.
So make your way inside. Once you are inside, go ahead and take your finger.
Sorry.
That's fine. Actually, if you want to keep going,
Keep coming in. You can sit anywhere along the edges. You're more than welcome to take as many photos as you want. Just know that flash photography is forbidden under all astronomy law. It looks like it's a little crowded over there, so you'll have to ask somebody to scoot. All right, so this is our Schulman 32-inch telescope, as denoted by the giant plaque that says the Schulman telescope. And this is the one that we're going to be utilizing tonight. Now, when you came inside of this building, is this what you were expecting to see for a telescope? Maybe sort of kind of, maybe you're expecting one of those really long pirate spyglass kind of telescopes. So that is called a refractor, and we do have one of those in here. It's right here on the top. Now, that is the first type of telescope that was invented. However, there is an issue with that kind of telescope, and that's size. The bigger you make a refractor, the longer it has to be. The largest refractor ever used for astronomy is actually in Wisconsin. That's the European Observatory. It has a 40-inch telescope, just about from here to here or so. However, it is 60 feet long. So you can imagine how gigantic that building needs to be just to house a rather modest telescope. Nowadays, most telescopes are reflecting telescopes that use mirrors. This was invented by a smart guy, you may have heard of him. His name was Isaac Newton. And so kind of a continuing evolving on that type of idea. So how these telescopes work is the light comes down from space, and right behind this big black piece of metal is that mirror 32 inches across, that primary mirror. Light hits that, goes back up towards the top, where you guys here on the side should be able to see a baffle that actually houses a secondary mirror that the light bounces off of again, comes back down, focusing through a hole in the primary, and out to the focuser right here. This is where all the oohs and ahs are going to be coming from, hopefully. Now, how many of you have looked through the telescope before? Doesn't matter the size, just any telescope. Okay? So we're going to go ahead and pass these around, and we want to make sure you know how to use them So the later on tonight, when it's pitch black in here and you're looking through the telescope, you don't look through like this. So you want this. There's a telescope there. You want this eye cup to either brush the bridge of your nose or your eyebrow. That's going to be where you're at the correct distance from the eyepiece to get the full field of view. We do want you to keep passing these around. You are not going to see anything in focus. It is missing a very vital part of the assembly. And the thing that spins does nothing. Just letting you know.
I tried it. It does nothing.
Yeah, it's actually supposed to give more eye relief by actually coming out a little bit, and so it just rotates because of that, but yeah, don't worry about it.
So you just see light when you look at it?
Yeah, they're just going to see blurred light
Yeah.
because it's not on a telescope.
Yeah.
Now you'll see that there is an eye cup on this.
So you want to practice your eye placement when you're using this. You want to look into the
What
barrel
is the size of this
so that you can
eyepiece?
see a dark ridge or edge. Okay, that's the field stuff. When you see that, you know you have the correct eye placement. Good.
The sky will be slightly grayer than even if it's dark sky, it will be gray
You'll have a little bit of gray on the background. Yeah.
compared to the dark sky.
Now these eyepieces do have quite a large apparent field of view, so that field stop is actually quite far out. If you find that you can't quite see the edge, that's okay. In fact, the eyepiece up here, about half of the population can't see the entire field of view of that eyepiece. And you literally have to like move your head around a little bit to see the whole.
Glasses. And if you wanted to with your glasses.
So in terms of specification, what kind of magnification they will
Let you see the whole field.
It depends on which eyepiece. It ranges from about 180 to over 300, depending on how crazy you want to be. If you really want to, we'll use the Barlow with the 11 millimeter and punch it to like 1,000, and then if you're like, that was a bad idea, let's go back down. So, if you're wearing glasses, you can either keep your glasses on, which is what I would personally do, and just push onto that eye cup with your glasses, just to get the same distance as you would without glasses on. Or you can take your glasses off. If you take your glasses off, we will have to give you a little sticker that says fiddler. Because you're going to be one of the people that needs to refocus the telescope for your own eye. Super simple, one knob on either side, and that is how you will refocus the telescope. How you know that you're in focus is that the stars look like little sparkly balls of light. They're not going to look like pinpoints like they generally do in the sky because of the magnification of the telescope. They'll have a little bit of a size to them, kind of be sparkling and scintillating a little bit, but they should be as tiny as you can possibly make them. If later on you look through the eyepiece and the stars look like kind of weird donuts or halos or something like that, it is way out of focus. At which point you can say, Geronimo, I broke the telescope, and we can focus it for you.
You might also want to mention the rotation of the eye.
So both telescopes do have a rotating diagonal. So depending on if you're Shaq or Danny DeVito, you can change the height of the eyepiece. It'll generally be more comfortable to look down into the eyepiece or just straight on rather than up into the eyepiece. If you have to be looking up into the eyepiece, we do have this invention that I made. We call it a step ladder. Yes, it is blurry.
Travis, are we able to put our phone camera up there and take a picture?
Magician never reveals his secrets.
Okay.
Yes.
So it's not easy, it's very difficult. Many times you won't get it.
All right. Now, by a show of hands, how many of you have seen a star during the day? This is a trick question. The sun is a star. You've all seen a star during the day. However, with a telescope such as ours, it is actually large enough and accurate enough to the sky that you can actually look at stars other than the sun. And in fact, excluding the sun during the day. If we were to point this at the sun, not only would it burn a hole through your head, but it would also melt our eyepieces, and they're a little expensive, so we obviously don't want to do that. I believe Geronimo is going to use his Jedi Force powers and have us point at the star.
By the way, folks, during the program, as we slew the telescope to different objects, we're going to be pulling all clear or heads up. And when we scream that out, it's going to be your signal to back away from the telescope. Okay? Once it starts moving, it's not going to stop. All right? If you're in the way, it's going to plow right through you. All right? So heads up. Here we go.
heads up, and then we have to unpark the telescope because we forgot to unpark it earlier. It takes a couple moments for it to unpark within the sky because it's slowing up. So let's go ahead and have everybody ready. Go ahead and use your Jedi Force powers, and I want you to move the telescope. Not the dome, the telescope. Come on. Come on. Do or do not. There is no try. There you go.
Yeah.
Who's doing that?
It's the automation.
Yes. Mm-hmm.